Welcome to Next Generation SMB in Windows Server 2025 on Windows vNext. My name is Ned Pyle. I'm a Principal Program Manager here at Microsoft in Windows Server Engineering. And I don't have a whole lot of time. These sessions at sambaXP are awfully fast. So I'm going to get right into my agenda. I'll be talking about changes in the security mindset of Windows and SMB, what's coming next for SMB, and show a fair number of demos to sort of illustrate some points about these new features and defaults. What is this security mindset? So we're starting another set of security campaigns within Windows, and very specifically within SMB. We've spent the last few years really focused on security-related pieces, making security the priority, making performance secondary, and making compatibility absolutely a distant third, which is a real, I would say, reversal of how Windows and SMB have typically operated over the last 25 years or so, 30 years or so. And that starts with a large number of new capabilities. So talking about vNext, talking about Windows Server 2025 here. In the year 2022, you started seeing some output from us. We started changing SMB compression behaviors. We started releasing insider functionality. The first was this thing called the SMB auth rate limiter. And then starting the first half of the next calendar year, we turned off guest auth fallback in Pro. We did the final removal of SMB1's being a client being on by default in home editions. We disabled mail slots, and we started requiring signing. So let's dig into these a little bit harder. So what is this auth rate limiter I'm talking about? It's a throttle for bad credentials sent to SMB. That could be NTLM credentials, PKDU, this local KDC. What is that? We'll get to that in a second. It has no effect on AD-based Kerberos. As you know, Active Directory-based Kerberos is a conversation between you and a KDC. That conversation does not involve logging into an SMB file server. It involves you showing up with a ticket later, having already logged in. So this rate limiter really is mainly about stopping local authentication guessing, or just plain NTLM-based authentication guessing. And what it does is just adds a 2-second delay by default between each failed login. You can configure that up to 10 seconds. It is on by default, and you can control it with PowerShell and group policy just by setting server configuration. And it's all done in milliseconds, so you can be pretty granular here. An example of this would be like if I could send 300 attempts to guess a password a second and do it for 5 minutes. That's 90,000 attempts in just 5 minutes. Against a 2025 server or a Windows 11 client with this feature turned on, that would now take 50 hours. So obviously the goal here isn't to stop brute force attacks. It's impossible to stop them given enough time and effort from an attacker. It makes it so nobody would want to do it. And they can go pick on some other protocol other than SMB for their attempts to guess passwords, because this will make them, an indigestible target for some bad guy. So let's see this in action. So first, I want to show you what the settings are. Now, this is on by default, so we'll show you that right now. It's set to 2000. That's obviously 2 seconds. So what I'm going to do is turn it off for the purposes of illustration, just to show you what it's like in the world of Windows today, before you get to vNext. And I'm going to run this little script I wrote. It's a very terrible little PowerShell script. And what it does is say, tell me how many times to try logging in. I'm going to generate a random password, and against some target and using some user. So I'm going to try and go against the C share with this admin account. And you can see it instantly responds. Let's do 50. And instantly responds. I'm doing upwards of 60 attempts a second here with my crudbag script. So let's turn this feature on. Back to the default. Now, 1 attempt. 2 seconds. What if I try 5 attempts? Can anybody here do that math? It's pretty obviously going to be 10 seconds. This is the world's most boring demo now. And imagine being the attacker. Your attacks that used to blast through and guess passwords now are taking forever. You're going to move on to some other target, and that's the goal. The next thing we did was turn off guest auth failback. Now, you probably know what that means, right? You try a password, it doesn't work, and then SMB server and the client are like, well, let's try guest. And then a bad person lets you in. Or a well-meaning but unsafe good person. So NASs, consumer NASs especially, very commonly used to allow guest auth as a way to simplify the consumer experience of not having to specify usernames and passwords. Hopefully none of yours here do that. But it's a very easy method to attack clients by just sending them some path. Don't need the user to have a good password. They connect. It allows them to connect through guest, and then it executes some nefarious payload, right? So Windows Pro now defaults to this being off. As you probably know, Windows Enterprise, Education, Windows Server, this has all been gone for years now. It's been off by default since Windows 10 in those spaces. And all that leaves now is Home Edition, still allowing this guest fallback behavior from the client. That's it. Then, and this is, you've been watching me for the last 8 years fight SMB1 and remove it from Windows in, a fairly uncommon thing to do for us to stop using a protocol completely and force the entire ecosystem to stop using it. So when I started, it was 45% of all SMB traffic was SMB1, about half. And now it's about 0.25. Effectively, it is entirely eliminated. And that means now with SMB1 gone from home and gone from all editions, we've won. That battle is over. This campaign is complete. And we've effectively removed SMB1 from the market. The next thing we've done here is disable mail slots. If you are somebody who grew up on Windows IT in the 80s or IBM IT in the 80s, you might remember mail slots. It's a completely unsafe file-based IPC method. You could do hilarious stuff like prank everybody on your subnet by blasting out anonymous messages using it. It's garbage. And so this remote mail slot capability is still available in SMB, and it was actually used in AD as part of BC Locator. It has been disabled by default now. You'd have to go and turn it back on if you wish to. I wish that you do not do it. It is officially deprecated. There's documentation online. We are not going to touch it anymore. We're not going to fix it. We're not going to do anything about it. It's going to be removed from the OS. And if you're still using it for some reason, you should stop. The next thing, and the first of like the super major new changes, is SMB signing is now being required. And that's on by default. So previously, domain controllers would require you when connecting to them to do SMB signing. Clients would require that if you connected to a share called sysvol or netlogon that it be signed. Now Windows and Windows Server have these things, has SMB signing requirements on by default. The SMB server in Windows client SKUs has it required. The SMB client in all SKUs has it required. This will stop relay attacks, attacker in the middle, phishing attacks, all the stuff that signing protects, but very, very, very broadly now. You can control a PowerShell, you can control a group policy. Don't query the registry. As always, use PowerShell or WMI's methods that PowerShell calls to see the effective state machine of what it is. Don't go look at the registry. Look and see what the effective state is. And if this doesn't work for some reason, you're troubleshooting this for some reason, these are our errors for signing has been tampered with, or the destination server doesn't support it, or the destination client doesn't support it. Obviously, those are not Windows, because Windows has supported signing since NT. The performance considerations somebody's going to ask, or think about this right away, is what does it cost for signing? It's mainly around cores, speed, count, utilization. When I do quick tests on fairly modern hardware, but not a particularly well-stocked machine, I see about a 15% reduction in throughput. Don't forget that you got SMB compression now for the last few years that would greatly offset that overhead, especially with large inefficient files. But ultimately what I'm saying is your customers, my customers, everybody's customers must test and decide if they want to keep this default on or if they want to opt back out of it into, being unsafe but fast. And this is my next big campaign. So you saw me burn myself to a crisp on SMB 1. Now it's going to be signing. This site is not online right now because I don't have enough things inside of it. I don't want to look mean to the few vendors I have found who don't support signing. But I'm counting on you to contact me and counting on you to tell your customers and users to contact us through won't sign SMB at Microsoft.com and to let us know if you find things that aren't supporting signing. And it's obviously not going to be Windows related. All Windows versions support signing and it's always enabled. This is about changing the required setting. In fact, if you're using 3.1.1 and claiming that your product supports 3.1.1, you're always using signing even before this change because that's an integral part of pre-authentication integrity. If something won't sign, turn it on. If you can't turn it on, you've got to upgrade that device, that app, talk to that vendor, whatever. Don't be part of the problem. Don't be that vendor because I'm going to be shaming you on that won't sign SMB page until you fix your stuff. Okay, so that's a big chunk of work, but we weren't done. The second half of last year, we really got up to speed. So we added something called NTLM blocking. We expanded dialect control. We added a new ability for QUIC called client access control. We added the option to do global encryption from clients. We tightened up the firewall rules. We added support for alternative ports in the client and server, and we had a sort of significant surprise in capabilities. So let's talk about these in turn. So what is this SMB NTLM disable option? It says, no matter what, don't use NTLM in SMB. Don't emit challenge responses. Don't actually even get to the part of supporting the NTLM SSP. Simply use something else inside of negotiate. In our case, it would typically be Kerberos, and that would be what we would want. We don't want to be part of the NTLM problem. I don't want somebody being tricked into sending along NTLM challenge responses for brute force, things for pass the hash. I don't want to be part of that problem anymore. This is a change in Spinego that we use. In yours, it would be something else. It is off by default, but it's going to be on by default before you know it. We will turn that on by default at some future release. Obviously, it's for remote NTLM. If you needed to use NTLM like in a loop back locally because you were in a work group, you could still do that, but you probably won't need to. Keep listening about that. You control this with PowerShell and group policy and the mapping tools themselves. So I can set it for the entire machine, just say I don't want to do NTLM, but I could also say I'm going to map this drive. Don't do NTLM. And you can even set exceptions. So let's say you've got 1,000 servers and 999 of them are Windows, and you got this one server that's not, and it doesn't support being in a domain, or it can't join the domain, or it doesn't support Kerberos, or whatever the excuse is. You can say, okay, for that server, I will allow NTLM, and I'll minimize my risk about talking to literally anything else, and we'll use Kerberos for the rest. Let's see this thing in action. So first, let me look at my client settings. And as I mentioned, by default, this is not on. Block NTLM is the name of this. Got a nice aggressive name. And so I'm going to go ahead and map a drive here to this server. And I'm going to be using what is obviously a local user account. Let me turn on Wireshark so we can see all this. Go ahead, I'm going to put in my password. And it's going to work. Scroll up here, and let's look at our negotiate, our setup request. Here's my setup. There's NTLM. It all worked fine. That's fine. Here I am. My local user account. Obviously, there's no domain being used. Okay. Now I'm going to go back. First, I'm going to unmap this drive. Disconnect. Now let's go back and turn blocking on. True. Yes. Notice how I'm not rebooting here. Notice how I never reboot in any of my demos. This is all on the fly stuff. Get this Wireshark going again. Map that same drive, same server. Failed. Nice, useful error. Understandable. No, couldn't find the server, access denied shenanigans here. And we can see the NTLM negotiate here is blocked. So this is part of phasing out NTLM overall. This is a part of again, change in the security mindset of Windows, where we are moving to a much broader Kerberos-based, NTLM deprecated, and eventually removed world. And that means we are adding iKerb, local KDC, IPSPN translation, and NTLM to negotiate, like I just showed you, options where NTLM is no longer part of a negotiation phase, but sort of up-levels you, upgrades you to Kerberos, and forces you to use something more secure. And so what are these things I just mentioned, these Kerberos replacements for NTLM? If you've got a lack of line of sight from a client to a KDC, we have a new option called iKerb. If you've got just local user accounts, work group, we have a local KDC. You want to use IP addresses, something which today will force you into NTLM. We have an option to set and look up IP addresses as service principal names. And this hard-coded or unnecessary use of NTLM, we are hunting down hard coding. We're going to force vendors to hunt down hard coding. And then also use this sort of blocking option like I just demonstrated with SMB. SMB is sort of on the cutting edge here. I want to bring these things up and talk about them a little bit. These aren't particularly SMB features, but SMB is one of the first ones to make use of it and is one of the largest to make use of them. So what is iKerb? That is initial and pass-through authentication. The IA, I guess, stands for initial, ignore the rest, authentication. I don't know. It's a terrible acronym. Kerberos v5 and GSS API is still used in this case. Basically, it's another security package like Kerberos or NTLM inside of the negotiate context. And you will need an updated client and target to make use of it, but you will not need anybody to change their DCs. The DC is just going to keep operating like it doesn't understand the difference. It will work normally. Kerberos itself is mostly unchanged here. What you're really doing is creating a forwarding option from clients through targets to DCs. Meaning I don't need to ever, as a client, see the domain controller. I don't need to set up KDC proxy, which is fragile and complicated. And I won't be switching over to NTLM simply because I couldn't get to the DC directly. And so my laptop that wants to connect to this Windows server, with normal Kerberos today, I would first talk to my domain controller, get some ticket exchange, do my password, login, etc., and then go take the results of that and hand a ticket over to the target, right? And if I couldn't do that, I would start using NTLM. But instead, with iKerb, this exchange process will just move. So now my AS request and my AS reply are happening through my target back to me. And now my TGS request and reply are happening through that target to the DC and back to me. And then my final conversation is just between me and the target like it was. Let's see this with a SMB sort of a twist in a demo. So I'm going to go ahead and map this drive over to the share. Now, in this case, I don't have access to the domain controller from my client, okay? But it mapped. How did that work? So what is the domain controller here? This is the 101, the .101 server. And if I look at my Wireshark on my target machine, you'll see my conversation here is happening between the target and the domain controller. And notice there's the usual conversation I expect from Kerberos, but my client finally down there, .59, is just at the end of the conversation, right there. So no NTLM, no line of sight to the DC. Now I open my share, open my file. Oh, and look, it's full of adorable Kerberos. Cute. Then there's this thing called local KDC. It is local users and groups with Kerberos. No domain controller. It's running on top of Windows SAM. It still requires IAKerb in order to figure this out because obviously there's no service principal names, there's no DNS. None of that stuff is going to be working at this point. It's just a peer-to-peer conversation. But it means there's no NTLM happening now inside of Windows without domains. And this is something we want to make sure we get operating with everybody so that Windows clients and servers are interoperable with your clients and servers, not just for SMB, but for local KDC. So now my laptop's entire conversation, thanks to IAKerb and having a local KDC to talk to, that's, the entire Kerberos conversation I usually have most of it with a DC is now happening just between these machines. And it's not a server technology. A couple of Windows laptops can do this as well. So let's see this with another SMB twist on it. So here's my destination server, my target. Got this account called local admin. And I've got this new service running, the local KDC. And so on my client, I'm going to go ahead and map a drive. Now, remember I had that account called local admin, right? So my user here is local admin. Put in my password, and it works. And if I look in Wireshark, over here at my session setup, GSS API. I look at the request, Kerb AP rec. That was a local user account. Straight to the server, no talking to any domains. Cool. The next thing we did, there's so much stuff, is dialect control. So allow and refuse a range of SMB 2 and 3. Right now you can get rid of SMB 1, you're left with the rest of it. Now I can say I don't want to support SMB 2. Or I only want to support SMB 3.1.1. I don't want anything else to work. So more granular control. This actually exists already since Windows 10 and Server 2019 as a client option. It was sort of semi-undocumented. It was not managed in any way. It was just some registry settings. So now we've added PowerShell. We've also added group policy. And it works for both server and client. And obviously you don't need to set a max. And then I want to talk about SMB over quick again here. So SMB over quick is a replacement for TCP usage. Generally speaking, right? HTTP3, DNS, and SMB started offering that a few years ago. It's secure and reliable. It's based on UDP. It always does encryption. It requires TLS 1.3. And it means you don't need a VPN anymore. And that typically turns it into running as a encapsulated protocol over port 443 by default. And it's, in the case of SMB, it's for telecommuters and mobile devices and cloud and high security situations. If you were keeping your eye on me over the last few years, we shipped it in Server 22, but only in Azure Edition. So if you were running in Azure or on Azure Stack and then running this particular kind of VM, you could use this feature along with Windows 11. And I just want to go through and show you this thing one more time so you can sort of remember what the experience is like. So here I am, I'm opening up some drive. I'm on-prem right now, I'm at my desk. And I open up some file, and it all works. This is all TCP, right? It's just happening automatically because we try TCP, and it works, and we connect, and you open up your file, and, the user doesn't have any experience they understand about how any of this works anyway, right? So if that user was to leave the office, sign out of their machine, and go across the street to a coffee shop, and then get back signed in and try to access their data, you know what's going to happen, right? So I open Explorer, I go back to my shared drive that, the IT department shares for me. And I go back to my share and I try to open it. Nothing happens. It sits there for 60 seconds. The experience is awful. You get some bogus error at the end from the shell. Thanks a ton. And it just stinks. So today, if I had my Azure Edition server, I'd go to it and I would enable SMB over quick. And I'm using the Windows Admin Center here. So I've delivered some certificate to that server. That certificate is crafted in a way that supports Quick. It also has names, subject alternative names or subject names of endpoints that I would use to connect to. And I could use a KDC proxy if I needed to, which we hopefully won't need anymore because of iCur. And I would turn this on. It's very straightforward and simple. And my client would just now be able to connect. It doesn't need to do anything because it already has a public key from that same issuer CA that's issued this cert for the server. And it works. Terrific. And there it is, all Quick. Nothing had to happen because we automatically try Quick if TCP doesn't work. So what we've added now is this thing called client access control. And that means mutual auth through a certificate exchange. That means you can block and allow specific clients or groups of clients based on an ACL. So you would set a client certificate and its chain, become part of this ACL. You identify them by a hash or by an issuer name for a group of machines. And as long as you're granted and there's nothing denying you, you can now access it. It's very, very granular control, which, with granularity comes enormous management. This is not something that you would enter into lightly because now you got to manage all these clients as well. And this mutual auth process is as you might imagine. There's a client hello, and then we exchange certificates. So I get a certificate back from the server. I send a client certificate along to the server. It's validated against that list. We make sure that mutual auth is working. We make sure that the certs are valid, et cetera, et cetera, et cetera. And then we let you in or block you. And so what does this look like in a demo? Now it's going to be a little grim PowerShell here because I don't have Windows Admin Center updated yet to support this. But this new option is requiring client authentication. And so on my clients, I will now need to come up with some automation or process to give them certificates, a client cert issued to them, get some specific information out of that client cert, and then also assign it. So first off, I got to assign it. I'm going to map the client side certificate mapping. So this is the Quick server I'm going to connect to. Here's a thumbprint of the cert I've been issued, my client cert. Just going to grab the thumbprint here. Obviously, all this stuff can be done through PowerShell. I'm just trying to make the demo slightly interesting. So I've got my thumbprint. It's in my store. And I'm going to give this SHA-256 hash right here of that certificate to my server. So someone's going to have to go and get that and then grant access for that client on the Quick server. So I'm going to grant access. This is my access control list for identifier type of SHA-256. And that is the hash of that client. And so now when that client connects, it can say like, oh, I need to send along this certificate to the server when it asks, and I can connect. And it does. So an extra layer of protection where you still have a username and password, but now you're having a connectivity to Quick itself is being part of this process. Almost done. Bear with me. We're in the home stretch. Alternative ports. Azure Files has this problem. ISPs block port 445. Lots of people have this problem. And ISPs block lots of stuff, but 445 is what matters to me in SMB. And that means you have to switch to a VPN, which no one wants to mess around with a VPN. And then in addition, we've already talked to some customers who said, well, I like SMB over Quick, but I don't want to use the default 443 port. I've got everything going over 443. I've got to be able to break some of this stuff out. And so we have finally given you the option to do alternative ports in SMB. For our SMB server, this is restricted to Quick. For our SMB client, you can do it over Quick, TCP, or already made transport. We don't care. And then Azure Files, they will do it for TCP at some point. And it's like it sounds, right? I can just specify and use a port that isn't 445, or in the case of Quick, 443. So I can just set, using PowerShell, a port on the server. On the client, I can map drives using these ports. Using any of the 8 million ways you can map drives. I can also set group policy on all this to configure things. And it's not listed here, but we're actually working on doing DNS SRV record option as well, meaning that you could be able to just set up in DNS what the alternative ports are, and the client will figure it all out. Then we give you an option for global encryption. So always encrypt from the client, regardless of target. In the past, you could use UNC hardening to specify I must do encryption, but you could only do it with specific paths. You couldn't just say everything. Now you can do just like you do with signing, just saying like either you encrypt or we don't connect, and I don't care who I'm talking to. And that's obviously for the most, highest secure environments who care about nothing but security. Performance doesn't matter. Compatibility, because this means SMB3 or bust, that's the most important thing. You can control with PowerShell and group policy just by turning it on. And it's got an additional audit option, just like we did for signing, that can show you like, well, let me see on my servers and clients if the targets of them or the clients of them support signing, support encryption. And then I can sort of get an understanding of this environment about whether or not I should turn this thing on, or maybe I'm connecting to stuff that doesn't support encryption or doesn't work with encryption. We also tightened up a very old set of firewall rules. So right now, when you install the file server role, we just open up a small amount of ports, for management and SMB for itself to work. But if you were just to create a share using the shell, right click properties and make share and stuff, you go into a set of firewall rules that date back to XP/SP2. And they would open up all kinds of stuff here, as you can see. So what we've started to do now is start removing things that are going to be opened up by default when shares are created. So starting with NetBIOS, 137, 138, 139, those rules are not set anymore. They are not opened anymore. And we are going to, over time, remove ICMP, LLMNR, and Spooler RPC from that list. So we get down to just basically 445 and 5445 for iWarp, and that'll be it. And then here's my surprise. SMB over quick in all editions for server. So Azure Edition still has it, but now Data Center has it, and Standard has it. If you want to use SMB over quick, it's free. There's no ARC, there's no subscription, there's no Azure, there's none of that. Nothing, no hidden fees or anything here. If you want to use SMB over quick, it's now broadly available in Server 2025 for the world. That's kind of big news. We hope that that really drives adoption now. So that means all that's left is to ship this thing. And that's a lot of stuff to ship, right? I've gone over guest auth off in Pro, global encryption from the client, dialect control for server and client, signing required, the auth rate limiter on, the NTLM disable option available, SMB over quick client access control available, alternative ports available, this firewall rule tightening process beginning, mail slots disabled, and SMB over quick for everybody. That's a ton of work we've piled in there. I'm sure you have questions. I'm sure you have feedback. I've got plenty of time here to talk about this, both here now and after. You can always just email me at nedpyle@microsoft.com. I really want to thank you for your time. It's always great to get out here and talk to experienced peers in the industry about a protocol that we own and love. Thanks so much.